Guys, in this video we are going to see an example of Laplace transform circuit analysis. Here the question is asking us to find out the VO of t. VO of t is the voltage across this capacitor. Okay. Now here what we are going to do is we are going to convert this time domain circuit into Laplace domain circuit. Then we are going to solve for the voltage. Then we convert this one back into time domain circuit using inverse Laplace transform. Now here these are the things we have to know in order to transform this one into time domain circuit into Laplace domain circuit. When we convert this voltage from time domain to Laplace, this will become V of t to V, capital V of S. Then this small I of t current will become capital I of S. Resistance will remain the same, and the capacitance will become 1 over SC, and also we will have a voltage in series. But in the question they have mentioned assume zero initial condition. It means this voltage is basically V of 0, right? Initial condition. Since they have mentioned this is zero initial condition, it means this will not be in our new circuit. Okay, now let's go ahead and draw our new circuit in Laplace domain. Okay, so here we are going to have a new circuit. This is our new circuit, and let's go ahead and plug the values. Okay, here we are going to have the current that's going to become capital IS of S, and this resistor will remain the same. This is still 10 kilo ohm, and this capacitance will become impedance, and impedance is going to be 1 over SC. Since the capacitance is 25 microfarad, this is going to be 1 over S 25 micro, but this is going to be ohm because now it's impedance. Okay, now we are interested in finding the voltage across this, plus minus VO of S. Okay, now first we have to convert this given current. We have the current source provided, that is small is of t 3 e power negative t unit time like u of t ma. Okay, now here we convert this one into Laplace domain. To convert this one we have to do the Laplace transform. If you do that for this Laplace transform of 3 e power negative t, you will get 3 over s plus 1, and the unit is milliampere, right? This is milliampere, so this will become milliampere. Okay, so this is the Laplace transform of the given current. Now we have to find, in order to find the voltage is equal to I times Z. So we have to find the equivalent impedance because we have two impedances in parallel, and this will be treated same as the resistance. And we know that when we have resistance in parallel, we do the product over sum, right? We are going to do the same thing here. Z equivalent is going to be equal to product over sum. Product is going to be 10 kilo ohm multiplied by 1 over S 25 micro ohm, and 1 over 25 micro ohm is same as 40 kilo ohm. So 40 kilo over S ohm, I just divided because micro is 10 to the power minus 6. If you bring this one to the top, that's going to be 10 to the power of 6, and if you divide 10 to the power of 6 by 25, you will get 40 kilo ohm. Okay, so this is what we get. Let's avoid the ohm for now. Let's keep this as K, and then we divide by the sum. This is product, and the sum is going to be 10K plus 40K over S. Okay, now to get rid of this S, we can multiply top and bottom by S, and if you do that, in the top we will not have S anymore because this SS cancels. We will have 10K times 40K, 10K times 40K, 40K. In the denominator we will have 10Ks because this S cancel, but here we will have a multiplication of S, 10Ks plus 40K, 40K because this S cancel, and this is what we get. Now let's continue with a different color because we have so much thing going on. So this is what our impedance is. Now we are interested in finding the voltage. So VO of S is going to be impedance times the current, and we know that current is equal to 3 over S plus 1, 3 over S plus 1. Since we have milliampere, let's keep the milli, okay, because when we multiply you will see that milli and kilo cancels each other. Okay, you will see that. And let's continue here. This one multiplied by the equal impedance, that is 10k over 10k times 40k divided by, here we can do one thing. If we take the 10k common, this will become 1s. So let's keep it as s plus 4, s plus 4. And if we take 10k common, we can cancel this 10k and this 10k, right? So this will cancel and we are left with this one. Okay, so this is what we have right now. From this one we can write our final answer. That's going to be 3 times 40k. 3 times 40k, and milli and kilo also cancel. This milli and kilo cancels. So 3 times 40, that's going to be 120 divided by s plus 1, s plus 4. Okay, so this is what we get VOS for VO of s. Now here we have two different denominators like s plus 1, s plus 4 multiplication. So here we can do the partial fraction decomposition. Now in order to do that, let's get rid of this one. Partial fraction decomposition. And you know that when we have partial fraction decomposition, we separate this one as, if we have 120 over s plus 1, s plus 4, we separate this one as a over s plus 1 and plus b over s plus 4. Now to find one of them, what we can do is we can multiply everything by s plus 1, and let's see what we get. If we multiply everything by both sides by s plus 1, we will get rid of this denominator. We will have 120 over s plus 4 right here, and this denominator will cancel a, and here we will have plus b times s plus 1 and over s plus 4. Okay, here we are going to take if s is negative 1, because we want to eliminate one of this, right? If we take s as negative 1, then we will get rid of this part. B part will be eliminated, so we can solve for a. Okay, so let's go ahead and do that. Here we are going to have a, and if s is negative 1, this is going to become 120 over 3. 120 over 3, that's going to be equal to a, and b will become 0, because negative 1 plus 1, that's going to be 0. So if you multiply, you are going to get 0, because this 0, right? So this is going to become a is equal to 120 over 3, then a will become 40, right? So a is 40. Now we have to find what is our b values. To find out that one, what we can do is we can do the same step. Let's get rid of this part because we need some space. Okay, to find out b, what we are going to do is we are going to take this 120 over s plus 1 times s plus 4, and if you multiply everything by s plus 4, you will get rid of this denominator here. So you will have a times s plus 4, and this s plus 4 cancels because we are multiplying now everything by s plus 4. Let's write this one down. S plus 4, you will get 120 over s plus 1, and here you will get a times s plus 4 over s plus 1, and here we will have b alone, right? Because this denominator s plus 4 cancels. And now if we take s is equal to negative 4, if s is negative 4, oh, this is not a good idea, because if s plus 4 cancels here, then we cannot make this one equal to 0. So we have to do something else. Okay, let's see what we can do. Here we have a is this one, b is this one, s plus 4. Okay, yeah, this is okay, because b will become 0. If b is 0, then we can say this is 0. No, if a will become 0, because if we plug s is equal to minus 4, a will become 0. We have to keep this one, right, because this has to remain in order to find the b value. So this one is going to be 120 over minus 4 plus 1, and here we will have b. Then that's going to become 120 over negative 3. B is going to be 120 over negative 3. That's going to give us negative 40. So we have a value and b value, so we can write our final expression. And actually I erased this part. This is the main equation. This was the voltage we found in this Laplace domain, right? Now we are going to write the whole expression like this. Now in order to do that, let's get rid of this part. Okay, so Vs of s, we found out Vs of s. Vs of s, that's going to be equivalent to a over s plus 1. A is 40, so 40 over s plus 1 minus, because we have negative 40 for the b, so minus 40 over s plus 4. So this is the voltage across this capacitor in the Laplace domain. Okay, now we had to convert this one into time domain. In order to do that, we had to do the inverse Laplace transform. V0 of t is going to be inverse Laplace transform of Vo of s. Okay, if we do that, that's going to give us 40 e power negative t. Then we are going to have minus 40 e power negative 4t voltage, and that's going to be the voltage across this capacitor in time domain. I hope this helps. Thanks for watching.